Hello, everyone, and welcome to the TDWI webinar program. I'm Andrew Miller, and I'll be your moderator. For today's program, we have an expert panel on modern data pipelines, and our sponsor today is Unravel Data. For our presentations, we'll hear first from Fern Halper with TDWI, and after Fern speaks, we'll have a panel discussion with Kunal Agarwal from Unravel Data and from Krishnan from Sixth Sense Advisors. But before I turn over the time to our speakers, I'd like to go over a few basics with everyone. Today's webinar will be about an hour long. At the end of their presentations, our speakers will host a question and answer period. And if at any time during these presentations you'd like to submit a question, just use the Ask a Question area on your screen to type in your question. If you have any technical difficulties during the webinar, click on the Help area located below the slide window, and you'll receive technical assistance. If you'd like to discuss this webinar on Twitter with fellow attendees, just include the hashtag TDWI in your tweets. And finally, if you'd like a copy of today's presentation, use the click here for a PDF line there on the left middle of your console. In addition, we are recording today's events and we'll be emailing you a link to an archived version so you can view the presentation again later if you choose, or if you'd like to share it with a colleague. All right, again, we will be discussing modern data pipelines today, and our first speaker is Fern Halper. Well known in the analytics community, Fern has published hundreds of articles, research reports, speeches, and webinars on data mining and information technology during the past 20 years. Fern is also a co-author of several dummies books on cloud computing, the hybrid cloud, and big data. At TDWI, she focuses on advancing analytics, including predictive analytics, social media analysis, text analysis, cloud computing, and big data analytics approaches. She has been a partner at industry analyst firm Hurwitz & Associates and a lead analyst for Bell Labs. Her PhD is from Texas A&M University. Please welcome Fern, and I'll turn things over to you now.
Great. Thanks, Andrew. Hi, everyone. I'm really glad that you could attend today's expert panel. So I'm going to kick things off, and I'll spend about 10 minutes discussing the trends that we're seeing at TDWI that make modern data pipelines important and what the modern data pipeline is all about. And then we'll move to our panel discussion with Krish and Kunal, and that will take up the bulk of our time, but be thinking about your questions because we will have an audience Q&A also. So I want to start off with the fact that the market is more dynamic than ever. And that's what I wrote here in this purple box. Organizations are realizing that they need data and analytics to compete. You know, for example, I mean, think about the issues that we've been having with supply chains, and companies need to better understand their customers. And all of this has led to a complex environment. So first, what we see happening is that organizations want to enrich their data sets with new data types. So those data types come from disparate sources, you know, ERP systems, CRM systems, yes, you know, other systems like SaaS systems, data from sensors, other applications, and so on. You know, and the data, of course, is more diverse. It's not just about structured data anymore. It's about unstructured, semi-structured, and even machine data. And of course, this data is also higher in volume. So for instance, many companies we talk to store hundreds of terabytes or petabytes of data. And against this data, organizations want to use more advanced analytics, such as machine learning and predictive analytics, to become more proactive rather than simply being reactive. They think that they have to be. And in order to support this diverse data, organizations are moving to the cloud, including cloud data warehouses and cloud data lakes. We see in our research that the cloud data warehouse is already in the mainstream of adoption, and the cloud data lake is in the early mainstream. And some organizations are converging their data warehouses and data lakes into one platform that's sometimes called a data lakehouse or a unified platform. And then, of course, to support this, data pipelines, which I'll talk about, but it's basically a set of processes that take data from source to target, are becoming more complex too. So traditionally, organizations have built their pipelines using manual efforts and use the pipelines to prepare their data for analytics. However, in this complex environment, sometimes that won't work. So for example, in a recent best practices report, it's actually a 2021 best practices report that was done by my colleague Dave Stoddard, 36% of respondents said that they need some improvement with their data pipeline development and operationalization. And 22% of respondents are looking for a major upgrade. So I add 36 and 22, I get 58%. So more than 50% want an improvement in their data pipeline. Now, again, this isn't about improving the data pipeline just to build some sort of new data pipeline. When we ask about what the primary motivation for evolving a data strategy is, it's typically for a business reason, which you can see here, which is just to support modern analytics, again, for insight and action to be able to better compete and so on. So I just wanted to make that clear. All right, so what is the data pipeline and the modern pipeline? So we're defining it here as a series of steps that enables data to get from its original sources to users' data platforms for BI, reporting, dashboards, analytics, etc. It's including ingesting, processing, filtering, integrating, and aggregating data to make it ready for business consumption. So it can provide this pathway and processes from data ingestion through movement and cleansing and transformation and loading and integration and replication and preparation, and enriching the data for analysis in, this complex environment. And, what we see, it's also making use of automation. So sometimes people will ask, what's the difference between ETL and data pipelines? I guess, modern pipelines I think of as being an umbrella term. And, you don't necessarily need to transform data in the modern pipeline. Also modern pipelines do bring new feature functionality to the table, for example, perhaps dealing with real-time data or using augmented intelligence that I'll talk about. So some new feature functionality sort of in these modern pipelines. So let's look at some of the challenges that organizations are facing with their current pipelines, because I'm talking about these modern pipelines. What's the deal currently? So what we see happening is that organizations might experience that data takes weeks or longer to access with some of the current processes they're using to build their pipelines. And really, when we survey companies, most of them say that it takes too long to get access to a data source. So in a 2021 TDWI survey, for instance, although 35% said that access to a new data source can take anywhere from a day to a few weeks, it was taking roughly 2/3 of the respondents weeks or longer to actually get access to a new data set. So that can actually, add a lot of time that you don't have. And so a lot of times organizations are having to write manual connectors. That can take a long time. And often, this is too long for responding to market conditions. Another challenge is that IT often has difficulty keeping track of all of the data sources that it's trying to connect to. So typically, IT owns the data access and keeping track of the data sources, and they may not have the tools or the platform processes to do so. Additionally, organizations want access to sources like ERP and CRM systems that I was talking about, the MarTech solutions that can be complex. So for instance, ERP systems might have thousands of tables and billions of rows of data, and that can make it hard to access the data in the systems. But organizations, they need to enrich their data sets because they need to do that to enable more powerful analytics. So that becomes a challenge. Another challenge is that there aren't enough data engineers. So the data engineer is a person who's responsible for the design and creation and maintenance of the data pipelines and making that data available to data scientists and data analysts and other data users. And when we ask enterprises what's stopping them from moving forward with analytics, for example, like machine learning, oftentimes they'll say, we need more data engineers. So they're responsible, for the data. They're also sometimes responsible for building out features, for advanced analytics models, for operationalizing those models, and so on. And that talent can be hard to find. Data engineers are often highly technical. They have experience, building these ETL, ELT pipelines. They're using Python. They're using SQL. They're using other programming languages. They can be expensive roles that can be difficult to fill. And sometimes the data scientist will act as a data engineer, but I would say that's not necessarily a scalable solution. Another challenge is that organizations sometimes end up with multiple data copies. There's pipeline growth that causes problems such as errors, managing multiple data copies, managing the pipelines, that can be a big issue as well. So, there could be a lack of information about data lineage in the downstream systems and how the data was manipulated. They may create multiple copies during transformation and aggregation. And that can be difficult to actually validate the data downstream. And then, of course, changes in upstream systems need to be reflected in the downstream system. So if there's numerous unmanaged pipelines, the data removed or changed upstream might cause problems in some or all of the data that's downstream, depending on how the pipeline was written and whether it's monitored or whether any lineage information actually exists. So you can get this out of sync situation occurring, again, causing errors. And then, of course, it can be hard for different personas to make use of the pipelines for self-service. There's a big move to democratization in organizations, but it could be hard for multiple types of people, the data engineers, the data analysts, the data scientists, who may want to actually access these pipelines to do so. So before I go any further, we wanted to ask, you all, what challenges is your organization facing with data pipelines? So these should look familiar because I just went through some of them with you. So the first one is it takes weeks or longer to access new data. We want to enrich data with new sources, but can't. There aren't enough data engineers. You can select more than one because it's a square box. Pipeline growth causes problems such as errors and management, or it's hard for different personas to make use of the pipelines for self-service. So let's give you a second here and see what you have to say. And then once we do that, I will just go through what some of the features that we're seeing in some of these modern pipeline tools are, and then we'll get started with our roundtable. Okay, so 50% of you are saying that it takes weeks or longer to access new data. There aren't enough data engineers. Yeah, there's errors. So lots of problems. So it seems like there's problems across the board in terms of the way people are answering this. Interestingly, we want to enrich data with new sources, but can't, which speaks to the fact that organizations are still, a lot of them, primarily using structured data for their analytics, although we do see that changing. Okay, so let's talk about some of the modern pipeline features. So the first, and I mentioned this before, is that they're automated. A lot of these pipelines have automated features as part of them. So I discussed how manually built pipelines can cause bottlenecks and be error prone. And so what we see is that these modern pipelines typically have some sort of automation feature. And automation can actually help to ensure consistency, enable organizations to scale. So for instance, some pipelines can ingest metadata and write ETL code automatically. Or they allow users to visually transform data and address data quality issues. Some validate the data as it's ingested into the pipeline using rules or some sort of machine learning augmented type of tooling that can recognize patterns, in the data that says that there's something wrong here. Others are connected to a data catalog, so information about the data is kept up to date automatically. So they're automated, they're also augmented, which I alluded to just before. So that means that advanced analytics, like machine learning, is actually embedded into the software to perform advanced functions. So for instance, some tools may have augmented data quality capabilities to identify poor quality data, so they learn on, what data should look like. Others can augment transformations and recommend a rank list of suggested transformations, along with previews and so on. So there's lots of features, that are automated and augmented in these modern pipeline tools. They also are pretty good at connecting to different data sources. So this includes a data warehouse and a data lake, but also the SaaS systems, including those complex ERP systems that I was talking about, the MarTech systems, and some of the other thousands of SaaS systems that are out there. And if they don't have a way to connect to it, some providers will actually provide you an easy-to-use interface to build a custom connector. They tend to be more scalable, flexible, and speedy, I have here, because obviously companies want relevant and timely information. And so they're designed to provide low end-to-end latency, and some solutions actually offer push-down support, which sort of goes into this next one here, that we're leveraging the compute power of the cloud for optimal performance. Some of them, use change data capture, which is the process of identifying, capturing, and delivering changes to databases, applications, and mainframe systems to a target database. So only the change records are copied, downstream. And they're also very comprehensive, so whereas the ETL process covered extracting data from source systems and transforming it and loading it into the target system, modern pipelines often cover the end-to-end process, as I was talking about, from data ingestion all the way to analysis. And they're often part of a bigger platform, that's in the cloud. This platform, or the tooling around modern pipelines also might include monitoring capabilities to actually track pipelines, how often they're used. They may be observing the data pipeline to ensure efficiency and reliability and performance of the pipeline. They can provide alerts when there is a problem, so monitoring and tracking and helping, to better manage your pipelines can be part of these new pipeline tools as well. And then pipeline vendors are also providing other services to process new kinds of data. I just wanted to mention this, things like text data. So some pipeline tools actually provide the functionality to process text data and do things like extract entities, people, places, and things, or concepts, which are words or phrases that indicate a particular idea, or sentiments like positive, negative, or neutral sentiment from text information. And then that information can be used by itself or fed back into the platform. So some of these pipeline tools actually enable that kind of thing as well. So those are my introductory comments about pipelines. And so let's get this panel started. So I'm going to hand it back over to Andrew to introduce Kunal and Krish, and we'll get started. So Andrew, over to you.
Thank you very much, Fern. And before we get to our panel discussion, just a quick reminder to our audience, if you do have a question, you can enter it at any time in our Ask a Question window. We will be answering audience questions in the final portion of our program. Now it is my pleasure to introduce our panel members for today. First is Kunal Agarwal with Unravel Data. Kunal is the co-founder and CEO of Unravel Data, and previously he led sales and implementation of Oracle products at several Fortune 100 companies. Kunal also co-founded Use.com, a pioneer in personalized shopping and what-to-wear recommendations. Earlier in his career, he helped Sun Microsystems evaluate big data infrastructure like Sun's Grid computing engine. Kunal graduated from Duke University's Fuqua School of Business with an MBA in entrepreneurial studies, and from Valparaiso University with an undergraduate degree in computer and electrical engineering. Next is Krishnan with Sixth Sense Advisors. Mr. Krishnan is an expert in the strategy, architecture, and implementation of high-performance data and analytics solutions. He is a recognized data thought leader, writer, and speaking at industry-leading conferences using user groups and trade publications. He is a certified Bill-in-Long professional. In 31 years of professional experience, he has been solving complex computing problems and focusing on solution architecture spanning all aspects of data journey, including data lake, data warehousing, machine learning, advanced analytics, and business intelligence for Fortune 1000 clients. His get-it-done approach has delivered data solutions intelligence, has delivered data solutions across terabytes to multiple petabytes of data volumes, and his specialty is performance tuning both new and existing data analytics investments to realize greater than 95% performance gains. Krish's focus in the last 3 years has included data fabric, data mesh, data pipelines, data workflows, and analytics delivery engines. A published author with 5 books, including CAMA, DMBOK 1.0. He is writing a book on OKR and data journey measurement. Krish is faculty with TDWI. He is also a senior principal and analytics strategist at Tricentral in Minneapolis, Minnesota. And you can follow him on Twitter at DataGenius. Please welcome Kunal and Krish, and I'll hand it back over to you, Fern.
Great. So welcome to both of you.
Thank you for having us.
So let me start. So Kunal, I gave one definition of pipelines, and we discussed some of the challenges we see at TDWI with modern pipelines. So how are you defining a modern data pipeline, and what challenges are your customers having that a modern data pipeline might help to solve?
Yeah, that's a great question, Fern, and you gave a pretty comprehensive definition there. So we've been fortunate enough to work with companies in different industries. And our firm belief is that every company will become a data company if they aren't already one. And seeing the use cases of all the variety of data products that these companies are creating will help you understand what a data pipeline really is. So banks are doing things like fraud prevention. You've got retailers who are thinking about the customer preferences and what the customers really want. And that dates everything from the products that they want to the prices that you want to set for them. Another one of our customers is a software company that's running a SaaS business. They really need to measure the subscription and the effectiveness of all of the offers that they've been putting out for their customers, right? All these decisions and all these insights are now gotten through data products. And data pipelines is the backbone for running any of these very critical business processes inside these companies now. So what these data pipelines are doing is taking data from all of these different data sources. So if you take an example of a recommendation for a music company, for example, right? You may be using a music app, which gives you recommendations. And those data sources could be, hey, what are you listening to? What songs and albums are out there? And based on your listening patterns, being able to give you recommendations for the next song that you should be listening to. So a data pipeline is ultimately a sequence of actions that's collecting, gathering, moving this data from all of these different sources to a destination. And the destination could be a data product or a presentation, a dashboard, if you may, and all the stages that it takes to clean up this data, transform this data, connect it together, and ultimately, give it to the data scientists or your business analysts, for example, to be able to make use of it. So modern data pipelines, just because our data sets are blowing up every day, there's just a lot more data to handle. So they need to be scalable. They need to be extensible. You may be using 5 data sources today. It may go to 20 tomorrow. Say, for example, you want to add in location data to improve your music recommendations. So you need to be able to add that without having to rewrite the entire thing. And then you touched upon this big movement from going from ETL to ELT, where it's extract, transform, load, whereas the world now is extract, load, and then you can do the aggregation and models after the load, which helps you do more exploration on your data, so you don't have to be rigid about what you want to do with your data first and foremost. It's just, hey, let's get our data into one place and then really start to uncover the insights that our data has. So those are the characteristics of modern data pipelines. And there's tons of companies and cloud providers out there that are trying to crack this problem in unique ways, some of which you've mentioned in the past. But besides the tools, it should all be, again, back to what do you want to achieve and, what are you really trying to drive from the data that a company has? That should dictate, what kind of a data pipeline or architecture you should have for your organization.
Yeah, I like the fact that you talked about data products. I like that you talk about scalable, extensible. I was taking notes while you were writing, and exploring the data. So those are all good things to add to the definition that I had put out there about modern pipelines. Hey, Krish, how about you? How are you defining a modern data pipeline, and what challenges are your customers facing that could use one?
Oh, absolutely. Fern, you and Kunal both have put some fantastic definitions, and I'd give you my 2 cents. from a consulting viewpoint, a data pipeline in a modern data architecture is the actual integration point enabling the true multi-cloud vision for any organization. That is where pipelines come into play, because we've heard people having the discussions, hey, we're an Informatica shop, we're a data state shop, we do everything in SSIS, we're always doing everything in Kafka and Python. Now, in the last at least 24 to 28 months, the discussions are more in terms of how many pipelines are you guys focusing on? Are you rewriting your pipelines from scratch? Are you leveraging what you wrote in your ETL and you're just packaging it as a pipe? So the conversation is becoming more moving towards what is a pipeline and how do I get to it? Customer challenges that I can name a few, right? Think of any company moving to cloud. If they're an on-premise model shop, they're going to the cloud is a laborious exercise. Their acceleration pathways are going to start looking at, well, can I, do a data mesh? Well, can I stitch a fabric? Now, when you get to those viewpoints of saying, can I pick something and lift and shift? There is no unique lift and shift mechanism to go to the cloud. That is where, pipelines come into play. That is where, in fact, I have watched a few of, Kunal's and his team's presentations. And one of their presentations talks on how good can you get going to the cloud if you use the right approach. When you actually take a minute to examine an architect, I believe we can serve those cloud migration challenges. And multi-cloud integration, another one, mega challenge. Data virtualization, one known way to resolve it. But if I go beyond that and say, now let's actually remove the cap and wear a thinking cap for a minute, I might virtualize, but if I don't pipeline and feed in what I want in the right way, collecting, acquiring, collating, distributing that data set at the right time, I'm not going to have integration. And that challenge can be answered well by the data pipeline. Those are my two opening points.
Yeah, that makes sense. I mean, we definitely see that data integration is the top challenge, with the cloud. And we also see that more organizations believe that they're going to have a multi-cloud environment. I think the average number is 2 that we see now, for those organizations that actually have cloud environments. So I mentioned some of the capabilities of the modern data pipeline, but Kunal, what do you see are the key components and capabilities of modern data pipelines? I think we talked about some of them, but, and why? What do you think really key needs to be there?
Sure. Starting off with a thread of cloud and multi-cloud, there's so many different systems and vendors within each cloud as well. That makes it even more challenging for any customer to be able to manage, create and then manage and then scale all of these different data pipelines. So when you think about components of data pipelines, you can really break them down into the stages that your data is actually flowing through. So you have your ingest, just bringing all of the data in from all of these different places. Then you got to store them somewhere. And we're starting to see more and more, convergence of what we used to call the data lake and the data warehouse, into one entity now. And then there's also this emergence of a data mesh now, which is, hey, don't store this data as a big blob. Let's store this data into its entity format so we can connect all of these different entities and have a more, abstracted view so we can actually use this data after that, right? Now, even bringing this data in and landing this data into the storage has these two schools of thought around, do I do the transformation before I load it, or do I load it and then do the transformation based on my use cases afterwards, right? And then the other components are, of course, all the analysis that you're doing on this. Fern, you touched upon it. What am I doing with this? Is this going to be a dashboard that my business runs on? Is this going to be a customer-facing front-end data product and application, like we were speaking about, like a recommendation engine, for example? Or is this going to be something that's improving my business operations? Like, is this a fraud prevention tool or a pricing tool or something like that? And then consumption part is almost always overlooked or thought about in hindsight, but that's where we feel it should always get started, which is who's going to be using this and how, because that determines the refresh rate, the frequency, and all the upstream processes that need to get aligned with this. And that entire alignment is the other component, which is called the workflow component of your entire data pipeline, right? How are you stitching up all of these different stages that your data is going through into an end-to-end, workflow? Because the consumer at the other end doesn't care about all the upstream stages, for example, right? They just care about getting the results at the end of the day. And one key component that we see along all of these different stages is just having observability of your modern data pipeline. Observability helps you ultimately improve reliability of these pipelines, that they work on time every time, and they ultimately improve the productivity of all of the data team members. The poll results show that there's not enough data engineers. The demand far exceeds the supply. And what we see is the data engineers that are present are spending more than 50% of their time just firefighting issues. So observability can help you eliminate or at least get ahead of all of these different issues. So your productivity is improving. And a lot of times, last but not the least, we see that businesses tame their data ambitions by looking at their ballooning cloud bills and cloud costs. And that also happens because of the complexity that these data technologies present. So observability can also help you get control and governance around those things so you can start to scale your data operations in a much more efficient manner. So that's how I would categorize the key components that any company that's thinking about having a strategic investment in data pipelines should be thinking through before they start to scale their data processes up.
Yeah, that makes sense. How do you differentiate between observability and monitoring?
Observability is a more holistic catch-all term. So think about it as an umbrella term for monitoring. You're looking at, again, it's back to the same data pipeline question, actually, right? It is what sources of data are you gathering? And then how are you interpreting and analyzing all that data for the different use cases that the people are looking at it with? So monitoring is more about presenting you with the raw information and letting you figure it all out, whereas observability is more akin to gathering more data sets so you can connect the dots between those different pieces and help the readers or the viewers of that data to ultimately be able to crack the code in a much more simpler fashion.
Okay, good to know. Yeah, the audience also. So Krish, how about you? What do you think are the key components and capabilities of modern data pipelines?
Let me put it this way again. If I wear my consultant hat for a minute, I can tell you two things at a minimum that I look for. One is reusability. The whole purpose of going to a data pipeline is to write components like the Lego building blocks, Fern. So you can take multiple different kinds of Lego blocks, and then if you have the right kinds of joints that you can assimilate through in building a Lego structure, you could compose different pieces and make it colorful, make it versatile, make it plug and play in a true sense. So I'm looking for reusability being a very common basic feature, and Kunal spoke to it. And I think most vendors today, if you would, from a vendor platform perspective, will say they do it, but how many of them truly support it remains to be seen. And the second feature that I think is a mandatory, which nobody should ignore, is automation. And Kunal, I can't say more than anything different than where automation plays is that if I can develop, test, and deploy, and my deployment takes care of an automation feature, which is a turn-on switch, I'm set in my journey. At that point, my team does not keep redoing the same thing. One, it's reusable code. Second, it is automated out of the box from the word get-go. To me, those are two mandatory features that I would go for. And anything that comes packaged with that, absolutely accepted. But these two do not go without them, for sure.
Yeah, I agree with you on the reusable. And well, I also talked about automation, so certainly agree with that. But being able to reuse parts of, whatever pipelines you're putting together, that will definitely help to manage it better. And the automation thing, is interesting too, which, Krish, I'll start with you on this one because you were just talking about automation. But do you think that automation and augmentation, yes, you do think that they're important? And, what are some other examples? Do you have any other examples to share, in terms of what you've seen there?
So augmentation, very, very, Fern, you and I have played with this topic for a number of years now, through our different research / conference discussions. When people say augmentation, they think they're going to add on something. And that add-on doesn't necessarily mean that you're adding on additional capability. It means you're adding on something to an existing baggage. May not be useful at all. So in order for an end user to appreciate the word augmentation, augmented intelligence is adding capabilities that bring a natural acceleration to the current processes. That is where augmentation comes to play. A live example I can tell you, sit in an electric car, Tesla, EQS, BMW, take any of these guys, or even take the one from Ford, take whatever you would like to. If you look at the augmented intelligence, all these cars have sensors. Now, those sensors continuously transmit information and continuously bring feedback, alerting you, the person in the driver's seat holding a steering wheel, not driving necessarily, but holding a steering wheel, transmits information to you. That's augmented intelligence. You are not taking decisions. The car is smart enough to do it by itself. It's promoting more capabilities to you so that in case of an emergency, you know what to do to react. To me, that's very simply put, a data pipeline on a cloud, instant reaction from an end user, all pieces met. So to me, that is where augmentation comes to play big time.
Kunal, do you have anything to add about automation and augmentation?
Yeah, absolutely. If you see the poll results, not enough people, too many problems, too important of a problem to go and solve. Automation seems to be the only way out, right? So what happens to a company when the data flow stops and the business relies on that, right? What happens when data gets lost and never reaches the destination? What happens if the multi-$100 million data product suddenly crashes and stops working, or is producing incorrect results, which is even worse? So some of the reasons for automation is, just let's improve the decision-making timeliness so that companies can actually get to those answers in a reliable, on-time manner. It's to obviously improve productivity with a handful of people that we do have in every company. It's to make sure that performance and efficiency is also top-notch, because we don't stop at one data use case, right? Every company that we work with, we see them starting off with one or a dozen use cases, and then it soon balloons into multiple dozens, hundreds and thousands of use cases, right? So when you think about automation, those are the friction points or the roadblocks that it can really help you unlock. So some of the examples are automating your pipelines, testing, for example. So some of the companies that we work with, they have realized is if you put these pipelines from dev to prod, where they were just getting made to now they're running production systems, there's usually a lot of problems with them. They could be error prone, they could be slow, they could be expensive, they could be unreliable. And they always looked at it in hindsight, and they always were reactive around it. And then they said, look, why don't we automate testing in dev? So when we are promoting these applications from dev to prod, we come up with a health score. And we test against certain criteria around are these applications healthy? And based on that, we give it a score from 50 to 100. And if it's below 75, then let's go fix those problems and ensure that we're only promoting healthy applications and data pipelines to production. So they've been able to automate that. Some have even gotten to automate root cause analyses and problem remedies, even in the production stage, where it's not just getting an alert and saying you have a problem, but it's getting an automatic action that if I've seen this type of a problem in the past, then do this. So creating an if this, then that kind of an engine. So all of these repeated problems just take care of themselves. And what this ultimately draws is like now the businesses can depend and rely on these data analytics. And that's been a major problem for helping us cross the chasm of going from, hey, this is just an experiment and a science project to this is becoming critical. There's business leaders who may not be technical experts just putting their dollars and their necks on the line and say, hey, this will work. And this product will actually drive our company forward. And that just has to work every time. So automation can help you bring agility as well, kind of to what Krish was saying too earlier, which is, hey, let's think about this not as one monolithic block. Let's break them down into chunks. Let's think about them as reusable building blocks, if you may. And can we automate, the first 3 stages or the first 4 stages of every data pipeline? Because that's about loading the data, cleaning the data, and then using it for all these use cases. But if my 5 data engineers have to do the same thing, and everyone is doing all of those steps, what's the efficiency gain in that? Can we create it one time? So we're using the first 3 stages over and over again, and only the 4th stage is where we're really spending time to extract value out of that data. So yeah, as a company, we're firm believers in automation. That's what we've created our software with as well. And we truly believe that if a company needs to move at the speed that it needs to, then automation is very, very critical, especially in the data journey.
And to add just what you said, Kunal, that piece, the first 3 steps and the 4th step, the process piece, if not today, Kunal, if people who hear this discussion, even if they hear this about 6-8 months after this, they're going to realize that they are going to be forced to go that route. So it is better for somebody to start planning and hearing and understanding. Absolutely, yes.
Yep. I have another question, which, it may be too soon for people to be thinking about this, given what we saw in the results of the survey, et cetera. But, I always think about analytics. So I'm thinking about, bringing data in for analytics. What should companies think about if they're building pipelines, say, for machine learning? I was talking about the data engineers, building the features, and, those features somehow have to get into the pipeline, recomputed, I guess, each time that a model is run. Maybe just a few words about that so people also know what they should be thinking about in the future. Krish, I'll start with you on that.
Well, to me, when I see people saying that, hey, we want to build machine learning models to satisfy either analytics or advanced analytics, I always first have a sinking feeling in the bottom of my stomach, Fern. I'll be honest. The reason being, people have this imaginary world they create saying, I've created, codex, and this codex is going to do this particular module Y, and this module Y will take care of removing all data quality issues I have and put me into, a point in time to start where I will have automated pattern recognition for example, run. The question that I ask multiple times is, what data quality features have you put in so that this code model Y that you have will take care of the problems and will cleanse your data and put you into that starting point. And then they start answering questions, and over a period of time, as they start answering, you find that they're chasing their own tail. And to me, that is where, hey, time out. If you ever want to do machine learning and you want to understand how to leverage modern data engineering so that you will actually take advantage of machine learning, then go back to the drawing board and start with the foundational pieces. Understand how you take care of data quality, how you take care of metadata, how you take care of data transformation. Now, if you exercise those three pieces, the last piece, data transformation, is going to put you into the thought process of a data pipeline workflow architecture. Now, you are ready to actually talk the machine learning talk, because you are teaching a machine to think like you. So how would you think to solve the problem? Solve it at that point and see if it is efficient, see if it is reusable. Now, check, check, yes, yes. Automation, test, yes. Consumer understanding, check the box, yes. Now you're ready to actually deliver machine learning from a ready perspective. Before that, if somebody says, I wrote this machine learning code and it does this, I find it tough to just buy it off, somebody's theory point, because theoretically anything is doable, but practically, is it delivering what you want? Is it accomplishing what you need? Is it giving you that efficiency? Is it giving you that acceleration? Those are the pivot points to discuss. Absolutely.
Yeah, start with the business problem. Kunal, do you have anything to add to that?
Yeah, I'll just take the business view of this, right? So when you think about technology adoption, machine learning and AI is one step behind data engineering, data warehousing, if you may, right? So wherever they are in the adoption curve, we think about them as being laggards, if you may. A lot of companies that we work with, everybody wants to do machine learning. Very few of them are truly doing it in a scalable fashion right now, right? So this is a very important topic. Now, the world doesn't sit still. We know that machine learning is creating competitive advantages for companies. And let's take that same example of music recommendation, for example, right? If we are both apps competing for, more ears, if you may, then my recommendation's got to be better than yours. It's got to be more pinpoint, where you go, I love that song. And everyone is trying to figure out how to give you a better recommendation now. Same thing with banks. They're trying to perfect fraud prevention so you don't have those kind of problems in your bank accounts, right? So what does that need? That needs your machine learning model to constantly update with new things that you're figuring out as being primary key elements that you should be driving towards your model. So we haven't spoken about streaming a whole lot, but streaming is an integral part of creating something that's repeatedly updated with new data coming in. If you're waiting for a day and Krish is a Spotify user, for example, and listens to his music tomorrow and he sees the same recommendations instead of new ones, he's not going to use it. So it has to be real time. It's got to be updated consistently, and the architecture should evolve for you to go and do that. So here, too, we always recommend, and we always see with customers that are scaling it at a large scale, that it is modular, it is following agile practices, it is using reusable pieces, but at the end of the day, you're automating the end-to-end from how's data coming in to how the model is getting updated. And that's super important, because otherwise you're going to be left behind. Now, scaling becomes a huge problem when you think about machine learning, right? Because if you start opening up too many data sources and data sets, how are you going to get that just-in-time model update? So that's another challenge for the crack, which cannot be usually simulated in dev. So you've got to see that in prod for, sometimes you have spikes in usage, for example, right? Whatever your business does. So be able to get that data set and put it in your model could become a challenge. And again, if you're late to the game, then that model doesn't make sense anymore for that day, for example, right? So those are some of the challenges that people have to think about. Scale being a key one, and real time being a key one when it comes to machine learning.
Yeah, I'm glad that you were able to bring in the real time aspect of that. So I want to leave time for audience Q&A because we got a lot of audience questions I see coming in. So let's see if we can do a lightning round on this last question here in terms of, what are some best practices for getting started with modern pipelines? So let's say what is the best practice for getting started? Kunal, I'll start with you.
Yeah, I think we've said it a couple of times. Have an agile mindset, borrow from microservices world, right? Create reusable building blocks that are modular, so you can avoid all that redundant work. And then implement checkpoints, right? Implement checkpoints between designing, testing, production phases to make sure that the quality, the performance, the cost of your data pipelines are where you expect them to be.
That sounds good. Krish, what about you?
I would agree with what Kunal said, and I'd probably throw in a sprinkle of adding documentation, because everything that one does, if you don't document, it will not live past the day you put it into production. So document it so that it's reusable from that perspective.
Love it. All right, so we have great. We have 10 minutes for Q&A. So with that, I'm going to hand it over to Andrew, who's going to take us through the Q&A. So Andrew, over to you.
Terrific. Thank you for that fantastic panel discussion. And as Fern mentioned, we will move into the audience Q&A here. With our first question, this is actually for the entire panel, but perhaps we'll start with Kunal and then we'll work our way to Krish. How do most organizations keep track of all their pipelines? Are there tools for this?
Yes and no. So when you think about pipelines, they're a collection of smaller stages of processing that are happening end to end. So there may be certain technologies that are giving them either that component view, but not the entire pipeline view. And some of them will show you what the entire pipeline is doing at what we call the DAG level, but not at the component level. And when it comes to understanding how your health of your pipeline is, you really need a combination of both. So it's a really challenging task, trying to stitch up the story and connect the dots and see these things end to end. That's actually one of the things that, we saw a big gap in, and something that we've rolled into Unravel as well, is to be able to show not only the end-to-end view, but also show changes and behavior changes in patterns of execution time and costs and efficiency and quality. So users can quickly get inside, check out what's wrong, which component is wrong, drill down inside them and fix that problem. Krish, anything to add there? Like, from the consulting side, from what you see?
DAG is the most important piece as far as I can think multiple times from an architect's viewpoint. And if you really know how to get to the DAG and then break it down, like Kunal just expressed, that is the key master stroke, if you would. But remember this, if you don't understand DAGs, do not venture into it based on a Wikipedia README, because DAGs can be as complex as someone wants to conceive them. And Kunal, I'm sure you've seen your fair share of those in your exercises. So I would definitely recommend, do not jump into DAGs until you're completely clear of what you're getting into. Director acyclic graphs.
Yeah.
Okay. The next question, and you might have already touched on this, but in any case, I will move forward. Again, this will be for the entire panel here. What controls should organizations put in place for automated pipeline tools?
Krish, you want to take that?
I'll first let Kunal take that, and then I would jump in behind him for sure. He has some points on this, I know. Kunal, you do the first piece.
Yeah, look, the controls are, you've got to think about not today, you got to think about tomorrow, right? A lot of people are just myopic in let's just get this thing done, which is fine if you're experimenting. But as a company is growing, their data needs are going to grow. So you need to put checks and balances in place, from day one. So what are you really looking for? You should always have a KPI dashboard that helps you understand the business impact that your pipelines are driving for you. Very, very important. Not a lot of companies do that. They're only measuring tech. They're not measuring business impact of these things, right? So that's number one. Does this pipeline generate millions of dollars for me? Yes, it does. Then if this pipeline is not working for a day, what kind of an impact can I have on my business, right? And if it is working, what kind of a positive impact does it have? So measuring that's super important. Measuring performance, which is your SLA-bound performance, right? And when do I want these pipelines to finish? As Fern was talking about, you could have downstream processes getting effective because the ETL or the ELT is not happening on time, for example, right? So if you know the SLAs of when this is supposed to finish, then you can make sure that all the upstream processes get done on time. They're all coordinated together. That's what we mean by performance. Reliability as well, which is this thing needs to run 5 times a day. What is the SLA for that? Is it finishing on time 5 times a day or not? Quality, which Krish touched upon, correctness of the results that you're getting out of this, right? Garbage in, garbage out, right? You're not going to have, you can spend all the time and have all of the data engineers and data scientists in the world creating the best machine learning models, but it's not going to be accurate. So making sure your data is top quality as well is another check and balance to put inside of data pipelines, right? And last, but certainly not the least, is the cost. Cloud costs creep up on everybody. I've never spoken to a prospect who said, we are under budget for our cloud bill. And I hope, Fern, if you can put up a panel question next time around, are you under and over your cloud budget? 100% unanimously, we say we're over our cloud budget.
It's the second challenge that organizations face is the cost.
Exactly. So putting those checks early, and not just about, optimizing it, right? That's the latter stage. Just even understanding who's doing what, getting a governance around budgets and how do you scale this within your organization, how much should you allocate to each user group, and then removing wastages and inefficiencies from that platform. Those are some of the checks and balances. So performance, reliability, quality, and cost.
Yeah, I would can I just add something there?
Of course.
About, when people think of automation, I guess, and controls, like to me, when that question came in and I heard it, I thought, oh, I'm not just going to trust everything that an automated system does. Like there needs to be some controls, to validate that, what went in came out and, those sorts of things, which you touched upon, in talking about governance and whatnot, over these systems. But how do you govern these automated systems, I think is going to be an issue that organizations are going to have to, really start thinking about. What are the controls I'm putting in place over these automated systems? Who's checking, that the observability reports, are, around this is, or make sense, et cetera, et cetera.
Yep. And the other piece that I would add to what Kunal and Fern just pulled out to the audience is, remember this. Every exercise starts with understanding where you want to go, which means do not forget your platform has to also talk about data observability in the modern data stack. If you have no observability, then don't go beyond. Don't say catalogs will answer or somebody else will do this or that. Nope. Data observability to data governance. That's a direct connect right there. And there is a ton of papers, articles, write-ups available on this topic at TDWI. And I'm sure, Kunal, your website must be having a handful of articles from your, experiences, right? So please read this because this is important for everybody to understand when you set this journey up.
All right. Well, I think we have one more question here. We'll try and squeeze it in before the end, and this might be a nice way to wrap it up. Kunal, we'll start with you here. Where do you see data ops and observability converging?
Yeah, and this is right where Krish left it off, right? So if you can't see what your data operations exercise is doing, you're flying blind. And hope is not a strategy. You need to really, really understand how your entire data pipeline lifecycle from designing, coding, implementing it, deploying it, moving into production, optimizing it, scaling it out from there is working. And observability across that entire data ops ecosystem, actually have it on my whiteboard over here at the back if you guys can see this, it's very, very important to understand how well you're doing in each of those stages and if there's any problems happening in those stages and how you can go and resolve them, right? The ultimate goal of this is to produce amazing data products in a fast, agile manner with a small team, because we'll never have a full-size team, right? So it borrows from DevOps practices, but not a whole lot, besides the point that you should really have a set of rules of engagement between all of the different members of the data teams and some tooling around that to make sure that everybody knows what they're doing, which game they're playing, and their positions in this game. And then if problems do happen, then they're able to resolve those problems in a quick and fast and efficient manner, right? And really deliver data outcomes for the companies at the end of the day.
Okay. Well, thank you very much to all of our speakers. That does bring us to the end of our time, and I would like to thank our speakers. We did hear from Fern Halper with TDWI, Kunal Agarwal with Unravel Data, and Krishnan from 6 Sense Advisors. I would also like to thank Unravel Data for sponsoring today's webinar. And I would like to also remind you that we did record today's webinar, and we'll be emailing you a link to an archived version of the presentation. Please feel free to share that with colleagues. And don't forget, if you'd like a copy of today's presentation, use the click here for a PDF line. Finally, I would like to remind you that TDWI offers a wealth of information, including the latest research, reports, and webinars about BI, data warehousing, and a host of related topics. So I encourage you to tap into that expertise at tdwi.org. And from all of us here today, let me say thank you very much for attending. This does conclude today's event.
Thank you, Fern.